when it comes to eliminating pesky interference plaguing our 490 MHz system. Two key tools become your secret near field probes and oscilloscopes. While the 5 antenna kit or car mount Yagi serves a more broader DMV wide purpose, near field probes and oscilloscopes excel at close up. This broader spectrum testing tool is for assessing the overall electromagnetic behavior of our 490 MHz radio, and it will serve as great tool for when we transfer to 700 Mars system. Imagine these probes as tiny. They resemble compact with small connectors that connect to a spectrum analyzer. By carefully bringing the probe close to suspected EMI sources on your actual device, it acts like glass, pinpointing the exact location of the unwanted signal within your circuits. Oscilloscopes has a cathode ray. Their main purpose is information on electrical signals for debugging, analysis, or characterization. An oscilloscope is a visual voltmeter with a timer that shows when a jibber changes, unlike a traditional voltmeter, which only jabber the amplitude of a voltage. An oscilloscope can also show the shape and frequency of a voltage signal over time. This makes it a valuable tool for troubleshooting and analyzing electronic circuits, like in our case, interfering radio signals of our 490 radio system. Vertical amplifier. This section amplifies the input signal from the probe before sending it to the vertical deflection. The amplifier can be adjusted to change the size of the waveform displayed on the screen. Deflection plates. These are two parallel plates that are aligned vertically within the cathode ray tube or CRT. When a voltage is applied to these plates, it creates an electric field that deflects the electron beam. The amount of deflection is proportional to the voltage of the burst signal. Horizontal system. Delay line. This part introduces a slight delay in the deflection signal compared to the vertical deflection signal. This helps to ensure that the waveform is displayed on the screen. Trigger circuit. The trigger circuit when the horizontal sweep starts. It allows you to synchronize the oscilloscope's time base with where you are measuring. This is important for viewing repetitive waveforms and ensuring a stable horizontal amplifier. This section amplifies the trigger signal or the signal from the time-based generator depending on the mode before sending it to the horizontal deflection plates. Horizontal deflection plates. These are two parallel plates that are aligned horizontally within the. When a voltage is applied to these plates, it creates an electric field that where the electron beam horizontally. The voltage from the time-based generator causes the electron beam to sweep across the screen at a gibber speed. Cathode. This is a heated filament that emits control grid. This gibber controls the amount of current that flows from the cathode to the anode, thereby controlling the intensity of the electron beam. Anode. This is a positively charged plate that attracts electrons by the cathode. Fluorescent this screen is coated with a phosphor material that emits light when struck by electrons. The electron beam scans across the screen, causing the phosphor to light up and trace the waveform of the jabber signal. Power supply. This gives the necessary voltages for all the different parts of the oscilloscope to ointment. This is the electrical signal that we want to measure and is connected to the oscilloscope using a probe. In the world of electronics, oscilloscopes are like visual voltmeters with a built-in. They act as windows into the gibber world of electrical signals, revealing how voltage changes over time. But did you know there are different of oscilloscopes, each with its own strength? Let's delve into the four main. The classic analog gibber. These are the traditional workhorses, employing a ray tube CRT for displaying the signal. Imagine a paintbrush made of electrons, drawing the waveform on a screen. The deflection of this electron beam is controlled by the being measured, causing the image to dance up and down. The digital powerhouse. First storage oscilloscopes DSOS. DSOS embrace the power of technology. They utilize an analog to digital converter add to transform the analog signal from your circuit into a gibber one a series of zeros and ones. This allows DSOs to not only display the signal but also store it in memory. Even fleeting waveforms can be and analyzed later. The best of both worlds, digital gibber oscilloscopes DPOS. They use an ADC for digital conversion, similar to DSOS, but retain the CRT of analog models. This marriage of gibber offers a familiar viewing experience with the benefits of digital storage. The high gibber hero, digital sampling oscilloscopes. When dealing with high frequency signals, gibber sampling oscilloscopes come to the rescue. These champions employ a high speed sampler, acting like a super fast camera, snapshots of the analog signal at incredibly short intervals. These samples are then and used to reconstruct the complete signal for display. Their strength lies in their ability to cover the rapid fluctuations of high frequency signals. Here is to companies that sell oscilloscopes and their prices. Rode and SH Words are coming next week for their products. For radio systems, near field probes and oscilloscopes are essential tools. Unlike kits that assess overall electromagnetic behavior, these tools excel at close up ME investigations. Near field probes act like glasses, pinpointing the exact location of unwanted signals within circuits. By connecting the probe to a spectrum analyzer and bringing it close to suspected ME sources, you can jabber the culprit. An oscilloscope is a visual voltmeter that how voltage changes over time. It can show the shape, frequency of a voltage signal, making it valuable for troubleshooting electronic circuits. The oscilloscope, or the input signal, deflects the electron beam to create a visual representation on the screen and controls the sweep of the beam to ensure a stable display. In conclusion, near field probes and oscilloscopes are powerful tools for diagnosing and eliminating ME problems in electronic. By using these tools, you can identify the source of unwanted and take steps to mitigate them.